All right. Hello, everybody. I'm Jack, CEO of SKALE Labs. Pleasure to be here. First off, I want to say this has to be the absolute best social media GIF for an invite for an event. Did anyone see that? It's really cool. It was an actual video. So whoever built that, well done. Nice work. Also, hey, I've had a blast here in Korea. There's a real thriving blockchain community, and there's so many events happening all around town right now. And it's also really interesting to see the development and the growth of the dApp community. I actually saw advertisements in a subway for dApps. And like, that's very, very different than other regions where maybe mass market is just being kind of advertised tokens. So really, really cool, really awesome to be here. And SKALE is very excited about this community. We're going to be hiring here. We're going to be hiring a solutions engineer in Korea. So if any of you fit that role or model, please pay attention. If you have a friend, we'd love an introduction. Okay. So I'll get going. Potentially. Okay, here we go. All right, so who's familiar with SKALE? Okay, we've got a few in the back. All right, great. So I'm going to give a high-level overview, talk a little bit more tonight about the plan and the steps, and actually specifically on the validator side and our incentivized DevNet that's launching. So we've been around for a little over almost 2 years, and we're a team of 25. We're headquartered in San Francisco. We also have an office in Kharkiv, Ukraine. We're 20 of the 25 are in engineering at SKALE, so we're very focused on building. We're really looking forward to launching our mainnet later this year as well, which is a theme, I think, of all the projects here tonight, and also the Multicoin family theme, which is cool as well. So Stan and myself have been doing startups since 2005. So doing deep tech startups. We both have actually backgrounds in cryptography. So my first startup was called Good Technology. We had a cryptographic secure messaging platform, and I like to joke we had this very, very great cryptography cert because Stan was running a cryptography lab at that time, working for the US government, and actually did Good's crypto cert in 2003. So we have a team also here tonight. So Christine runs solutions engineering, Jenny runs marketing. All right, so we also have a dual structure, which people have talked about as well tonight, with a corporation in the US and then a foundation abroad. So, and a big piece that's critical because we, passing assets to the foundation, actually running a decentralized network is a requirement in this space. You can't just trust corporations. So we've transferred all those assets, and as soon as the token goes live, we have on-chain voting for any economic decisions around the protocol. Okay, so we were very excited today to announce a new financing. So brought on, in particular, Hash, you'll see, who made an investment in this last round and is supporting us in Korea. We'll be, as I said, hiring and putting a lot of effort into this market. All right. So really quickly, just wanted to take a second to talk about why we're doing this. This was like the quote back in the aughts. It's like, how do we disintermediate middlemen, create better, more usable, more optimized systems, but you're doing it from a centralized perspective, and then you become the new middleman. The new play is really about creating new business models. So it's your margin is our opportunity, and that's where you start dismantling these structures and creating real network effects. And that's what got me excited about the space. I've been doing machine learning and AI startups for a long time, and that is obviously hot, but the business model innovation and the implications of cryptography and the implications of blockchains are what inspired me to come devote my life to this a few years ago. So, so how do we enable this though? And so what we need is a decentralized cloud, and we have to have a performant cloud. It has to be cost effective, has to be secure, and it has to be decentralized, or we're really just passing trust on to another intermediary, right? So decentralization is key, and this is true for any project, anyone building a decentralized cloud. So we approach that through building an elastic blockchain network. What this means is Scale is really a network of many, many blockchains. 1,000 nodes in the Scale network can run 8,000 independent blockchains if all of these blockchains are being run at the smallest increment. Part of this too is making a blockchain network that's configurable. So one size fits all is how enterprise software started too. You'd sell a piece of on-prem software for millions of dollars, and Accenture would come in and then have to literally get in and change the code. Configuration was a result of SaaS, was a result of cloud software and getting rid of these hard constructs that required hard coding to change systems. And we all know in blockchain, if you do that, you've created a huge mess on your hands of having forks. And so we're trying to create configuration from the root system, from the core system. And it's pretty simple at the start. I'll get into the options, but most robust performance systems have to start really with the core features when it comes to configuration. All right, so, and sorry, our slides are not perfectly displayed here, but bear with me. All right, so this is an Elastic blockchain network, but it is very purpose-built for Ethereum. We're completely devoted to the Ethereum community. We're devoted to supporting Ethereum developers. So our goal is that if you build a dApp for Ethereum, it is minutes to get live on the Scale network. It's a little more time if you need robust interchain messaging transfers, but we still have a lot of like out-of-the-box code samples and support for you. But that's our goal. There are developers there's pain there, and there's a huge, robust ecosystem growing. And so that's where we spend our time. That's where we're focused. Even though we like to talk about building this big decentralized cloud, we're trying to do that in conjunction with the Ethereum network. Okay, so Scale. So you have your Scale chain or your S chain. What does it do for you? So each large chain can do, any chain can do sub-second block times. Each large chain can do 2,000 transactions per second. You can also run full state smart contracts, so EVM lives on every Scale chain, or EWASM as soon as that support comes out. You can also do storage. So each Scale chain, because we have a subset of validators working for each chain as opposed to the entire network needing to manage state and storage for that particular dApp, you can do storage. You can also do machine learning. You can integrate pre-trained TensorFlow models into the smart contract, and there's some cool things you can do there I'll get into. You can also message from chain to chain. So you can update state and message between Scale chains or back and forth to the Ethereum mainnet. All right, so side chains. Side chains are not very secure, right? I think we all have come to an agreement on that throughout the industry. And the issue is that with a large set of validators, there's obviously more validation happening. Getting 2/3 to go Byzantine is far more difficult. So when you have a small set, now hey, you carry less state, you carry less weight, it's faster, it's more cost effective, but you lose that security value of having a larger set of validators. So our goal is to try to be able to create these shards or subsets of validators that work on each particular Scale chain. But the hard part about that is randomness and rotation and creating the right incentive structure. So that's something we've been working on for a long time. We use BLS threshold signatures in conjunction with DKG, with distributed key generation, to come up with randomness. And so the very simplified version is every single node in the network is coming up with a random number that then is immediately compiled and added, and then we use threshold signatures to sign off on that random number. Then we use distributed key generation, and then it ends up being a very, very secure way to create randomness. And then these validators, once they're in the network, can become stale. Eventually, they start recognizing they're working together, so you have to rotate them. And again, you need randomness in order to properly get access to the right nodes, swap them, and rotate them. And then stake is incredibly important. So we need to have stake. You need to have penalties. It can't just be carrots. You also have to have sticks. And you have to start with really a great set of validators. Okay, so that's really the high level of the RRI, I like to call it, where an elastic blockchain or elastic sidechain network is very different from a static sidechain where there might be one sidechain and then you're required to use plasma or state channels, or you're really playing with fire. Okay, so going to get in a little bit to the tech and the architecture. So how is this enabled? So every node, as opposed to having many different roles for different nodes, each node actually performs one job set for the network. So there's a node core, and again, this is all Dockerized. These are containers, and every node core has a piece. Sorry, this is a little blurred, but a piece dedicated to validator orchestration, node auditing, and administration. Okay. So what's happening is this node core actually works in conjunction with the Ethereum mainnet, and there's a set of smart contracts that live on the Ethereum mainnet that also have a lot of complex logic built in that work in conjunction with the node core to do, to understand what availability is there, which nodes can we deploy more, deploy to new chains, how can we rotate these? So also the stake, when the stake, it doesn't go into the SKALE chain, the stake in the network actually gets locked into the Ethereum mainnet. So we leverage the security of the Ethereum mainnet for the stake in the SKALE network. However, custody is happening in the SKALE network for dApps. Okay. So outside of the core, then we have, you can see all these other containers. Actually, each one could be running on a different blockchain. So stake.fish might be running SKALE nodes, and one node they might run might have 128 different SKALE chains or 128 different dApps. There might be 65 gaming dApps and 30 DeFi dApps, and we might have a whole mixture. And then as a node operator, you don't care. You're just putting resources into the network, and then that computation is being pooled together in an autonomous, decentralized fashion and providing resources back to the network. So you could also, you might have big requirements for storage, high throughput requirements. You may not want to have multi-tenancy. And so you're able to actually buy the entire or rent the entire chain and instead of a subsegment. And so getting into configuration, we allow people now, when the network launches, to opt to configure based off of size, cost, and privacy. So I might have a small budget. I might just want to test out my SKALE chain, or I might want to run multiple chains. I might use one for storage, one to execute my smart contracts, something for, who knows, something else. It's interesting the way this industry is evolving fast, but I might be, leveraging these small chains to do certain tasks. I might use a large chain for a more enterprise grade, a DEX or something that needs more throughput, more power. But the security ramifications are the same across every chain, whether it's multi-tenant or not. I also have privacy here. So we'll be launching SGX later this month. So you have a secure enclave within each node. So there's a trusted execution environment. And what that means is you can actually make the transactions private or not based off your use case as a dApp. And again, this, by the way, is one of these features that we walked into, because when you use BLS threshold signatures, you need to use SGX for the key storage. It's like, oh, well, then guess what? The good news is we also get privacy. All right, so decentralized cloud storage. This is actually something else we, sometimes accident is the mother of invention. We saw a need for machine learning to and pre-trained models to provide value as oracles put inputs into smart contracts. One use case is fraud detection. Another one is price prediction. Another one is image recognition. So imagine you have a social network and all of us are part of a group and we say, hey, let's just create this rule. This is a cat social network, so if anyone puts a picture of a dog, the smart contract rejects it. Now that's a very cleansed rule of how a group may want to censor themselves that they all opt into. But we thought, hey, people are going to need these types of controls, or issues could arise that no one wants to deal with. Then we realized, well, in order to enable that functionality, you actually needed storage. And because storage is not living across the entire network, it's living on each subchain or scale chain, then all of a sudden it's not incredibly costly and expensive to run storage on the scale chain. So each scale chain, Ethereum virtual machine is acting as the call and store function. And so we modified EVM, and then we just use the storage in the container. So it's actually not that hard. I mean, it was not easy, but conceptually, not rocket science. And that's open source. Anybody can use this. So feel free to check out the GitHub. Yeah, so we launched Scale ML. We actually built machine learning really early last year, I think in March. We didn't talk about it because, frankly, there's just too many things introduced at one time. But we talked about storage. Storage ended up being more valuable than running machine learning models. But we launched it at Harvard at ETH Boston a few weeks ago, and it's some amazing, amazing things built. So really cool to see how people took that idea and ran with it and started innovating in ways we hadn't even thought of. Okay, so interchain messaging, this is one of the hardest things that we had to accomplish. It seems like doing the consensus model and threshold signatures and understanding resourcing and all the things that need to happen for the rotation and the chain creation and chain destruction and dead node removal, all these things would be more hard, but this was really tough. Christine can attest to this. But now you can do, it's essentially a two-way peg. So we can whether it's ERC20, 721, ETH, it can be locked in a smart contract on the mainnet. It gets cloned, it runs in Scale. The end user through Taurus or Portus or Bitsky or MetaMask is interacting with the dApp and doesn't even need to know they're using the Scale chain. So they say, okay, I want my money out, I'm leaving, and then we run ConsenSys runs on the Scale chain. Less than a second, it notifies the mainnet, ConsenSys is run, the user has their assets back. There's no 7-day wait period, there's no issues, it's just fast, seamless. We'll eventually, we have launched Bitcoin, so you can have Bitcoin wrapped and cloned and running in a Scale chain and use the entire Ethereum ecosystem. Other assets that come out that are being utilized will support. Okay, there we go. So we're very focused on interoperability. We're kind of living in the Ethereum ecosystem. We're at every Ethereum hackathon. Our goal is that out of the box, if something works for Ethereum, it works for Scale. So it's not always completely that easy. It takes a little work, but for the most part, we stay on top of all the releases, and anything that happens on Ethereum, you have instant interoperability with Scale. So, okay, talking a little bit more about traction and the project and where we are and where the community is. So we launched the testnet last year in December. Since I've had 48 submissions at hackathons this year and had some very cool stuff built, and it's all on DevPost if you want to check it out. We have now 23 dApps in the Scale Innovator program where they get access to Scale chains, they get access to Christine and her team as far as getting hands-on engineering support. We give them access to investors and co-marketing, et cetera, and have about 85 in the broader pipeline. We are trying to slowly bring them on board. Just we don't want to provide any bad service experience, so eventually we'll open those doors and anyone can use a system, especially as we all know how these platforms work, right? The better your documentation gets, the better your education materials get, the more self-serve these things are. Finally getting there, it took a lot of hard work, but now you can actually come and get access to a Scale chain and learn in a self-serve model. Okay. So we have 10 validators right now running Scale around the world and the Scale DevNet. It's the Fuji release. We had Mount Tam was a release last year. If anyone's been to the Bay Area, it's probably not even fair to call it a mountain. It's more of a hill. We had to start simple. The next phase was Fuji, and then we're launching Kilimanjaro later this year, and eventually we'll launch Everest when you don't want to summit Everest too early, or where are you going to go? So. All right, but really excited about the validators running and bringing on more into the program, and then eventually rolling out an incentivized DevNet. So here's our timeline. Talked a little bit about it. Want to talk a little bit about what we're doing with, and just a quick overview. I know we have a validator-focused event here somewhat. So this is our testing schedule. We'll be launching SGX to test, and then our delegation workflows, and then really roll into security hardening, and then the exact date of a mainnet launch and a compliant way to get tokens into hands of people that want to participate in networks is actively being worked on, and we're going to have something exciting to announce pretty soon. So, okay, so that being said, I won't get into all these details, but hey, thank you. Been a pleasure. You can get in touch with me here and our team there. Okay, thanks.